Hey guys, it's Mr. Gyerman, and welcome to the start of remote learning. So we are officially learning new things, and we are done with the review section of online learning. So basically how this is going to go is I'm going to create these slideshows. I'm going to record a video of me talking and explaining over it. I'm going to post that video online, and there's going to be assignments embedded throughout the video. Those assignments are going to be what I count for attendance and participation. Let me know that you're following along with me. Um, those assignments are going to look different every time. Sometimes it might look more like a quiz, like today is going to look more like a quiz, but other times it might be an activity that takes you onto other websites. But I'm going to have some way for you to show me that you participated in the lesson for that day. Um, and these slides will be posted online on the Google Classroom. And the office hours are still open. Those will be used for more direct instruction. Any questions you have about this, anything that didn't make sense and you want to talk more about, that's what those office hours are going to be for. And the last little part about Google Classroom. So basically, Google Classroom, I want you guys to check that every day. Everything, I'm going to say that's going to be the one place you need to check. Everything I need you guys to know, I'm going to put on there. I might take you onto other websites. For instance, I'm pretty sure this video is going to have to be watched on YouTube. But everything you need to know, anything that's going to take you to other websites, is going to be posted on Google Classroom. I'm trying to make it so you only need to check there, and that'll tell you everything you need to know moving forward. Because I know there's a ton of different information coming out from all these different places. So, trying to post everything I can on Google Classroom, making sure that's the one place you need to go. So, this lesson is on chemical equations and reactions. That's where we left off once we finished our moles unit. We finished it with the lab just about, and we were ready to move into chemical equations and reactions. So that's where we're starting. So, chemical equations and reactions, what are they? So, the book definition of a chemical reaction is the process of one or more substances, and when you hear substances, I want you to think atoms and molecules, changing into one or more new substances that have different chemical and physical properties than those original substances. So, we have atoms and molecules changing into new substances. What's happening there is they're changing their bonds with each other. So we've talked about how we have a bunch of different atoms being bonded to each other through covalent or ionic bonding, and that creates our compounds. So a chemical reaction is basically just the rearranging of those atoms and molecules into new atoms and molecules. And how that happens is they change their bonds with each other. There are many different kinds of chemical reactions. We're going to work on classifying them later. But I don't want you guys to think of chemical reactions as something that only happens with a chemist in a lab. Chemical reactions happen all around us all the time. They happen within our body to keep us alive. They happen in the earth around us. There's chemical reactions when you make breakfast, when you on your way to school, when we used to go to school. So they happen all around us all the time. How do we know a chemical reaction has occurred? So, chemical reactions cause a change in energy and substance. When I say substance, I mean it causes a change in the actual substance that is present. So it changes one atom or molecule into another. But sometimes that's hard to just see with your eyes. So there are a couple different signs that we can look for to tell us that a chemical reaction has occurred. While there are signs that tell us that something might have happened, just because we see a sign does not mean a chemical reaction has definitely occurred, though. So we use these signs as evidence, but by themselves, they are not proof that a chemical reaction has occurred. To know for sure that a chemical reaction has occurred, we would need to do a chemical analysis of that new substance. We basically need to test that new substance to make sure it's got different properties. Remember that each element in substance, like each element on the periodic table, has its own properties. It's got its own density, it's got its own melting point, it's got its own boiling point. So if we were to test a new substance at the end of a chemical reaction, and that new substance had different properties, then we can say, yeah, that this substance was not here before the reaction occurred, So a chemical reaction must have taken place. But we don't want to always do that. So there are things we can look for to tell us that a chemical reaction has occurred. Also, a state change, basically changing between a solid, liquid, and a gas with the same substance, is not a chemical reaction. So boiling water, freezing water, those are not chemical reactions. Earlier in the year, we played with some liquid nitrogen and we made some balloons expand and compress. That liquid nitrogen, while it was really cool and interesting, but the liquid nitrogen turning into a gas, that's not a chemical reaction because it was just going from liquid nitrogen to gaseous nitrogen. So here's a list right from your book of evidences of chemical change. So as I mentioned before, chemical reactions cause a change in energy and substance. So we've got changes in energy and a formation of a new substance. Those can be used as evidence of a chemical change. But as I mentioned previously, just because one of these things happens does not mean that a chemical reaction has occurred. So, for instance, a reduction or increase of temperature. If you were to leave a metal bar out in the sun, that metal bar would get hot. It would absorb energy from the sun. It would increase in temperature, but that is not while that might be evidence of a chemical change in certain situations, that by itself is not a chemical change. We have to look a little bit beyond just looking for one of these signs. So once we know we have a chemical reaction, we need to be able to represent it. And that's what's most important about this lesson, being able to represent our chemical reactions. Those are done using chemical equations. So chemical equations, just like an equation in math, it's going to be, you've got something to the left and the right of an equal sign, basically saying that they're both equal. But instead of an equal sign, we're going to use an arrow. And it's going to make more sense once I show you guys one. But the word equation still means we've got something that equals another thing on the other side. Chemical equations are like recipes for chemical reactions. Basically, it tells us what we need to have the reaction, what we're going to get from the reaction, and if there's any special conditions that need to be met for that reaction to occur. So we've got a couple key parts, and they're all broken down on the next slide. So we have our starting substances, our original substances, our original atoms and molecules. Those are called our reactants. That's what we start with. And our end substances, what we end up with, are our products. So everything to the left, on the left side, is a reactant. Everything to the right is a product. The equation's also going to tell us the chemical formulas for each substance. And remember, those chemical formulas are specific to that substance. These cannot be changed. It changes the entire substance if we change our chemical formula. So the chemical formula for water is H2O. The chemical formula for sodium chloride is NaCl. Then we've got aluminum oxide, Al2O3. We have those subscripts to tell us how many of that element's atom is in that molecule. But that substance, that chemical formula is very specific to that substance. If you change that chemical formula, you are changing the substance entirely. That's not the case with coefficients. Coefficients tell us how much of that substance we have in there. So we can't change the 2 in H2O, but we can add a coefficient to say we've got more H2O in our chemical equation. And this becomes more clear on the next slide. And we can also say any special conditions that need to be met for the reaction to occur. We're not going to deal with a ton of those right now, but that can be shown in a chemical equation as well. So here we've got a chemical equation, and we've got it broken down into its parts. So this entire thing right here, everything in this box is considered the chemical equation. We've got an arrow, basically that acts as our equal sign in a chemical equation. It tells us we have something on the left that turns into something on the right. And like we talked about, there are different groups and different different pieces of this chemical equation we need to know. So everything to the left of the arrow is a reactant. This is what we start with. So in this chemical equation, we start with magnesium, Mg, and we start with oxygen, O2. So the reason why O2 has that 2 right there is because we're working with molecular oxygen. Oxygen only really exists by itself in a diatomic form. It only really exists as this molecule. We breathe in O2. Our body runs on O2, not just one atom of oxygen. It's got to be 2 atoms of oxygen molecularly bound. So we've got magnesium, we've got molecular oxygen, then we've got this arrow. This arrow means yields, and basically it acts as that equal sign from math. It tells us that we've got everything on the left turning into everything on the right. So we've got magnesium and oxygen, and we say in this chemical equation that represents a chemical reaction that's happened, it turns into magnesium oxide. It takes 2 pieces that were not chemically bound together and says they're going to end up chemically bound together with the formula MgO, magnesium oxide. So we've got our reactants on the left and our products on the right. So O2 is a reactant, magnesium is a reactant, and then magnesium oxide is a product. We've got a couple more parts here, actually just one more part. We've got these coefficients here. So remember, we cannot change our chemical formulas. Those are specific to that substance. If we're creating magnesium oxide, we cannot change the chemical formula for magnesium oxide. But we can say that more magnesium oxide will be created. It's still magnesium oxide, there's just now 2 of those molecules, or 3 of those molecules, whatever our number needs to be to balance the equation, and we'll get into that in the next lesson, balancing equations. Right now I just want to get into the parts. But our coefficient tells us how many of that molecule we have. So we've got 2 atoms of magnesium plus 1 molecule, but that molecule has 2 atoms of oxygen, yields us 2 molecules of magnesium oxide. So we'll do a little sample of balancing equations here. Basically what balancing equation tells us is that the total amount of atoms on the left side equals the total amount of atoms on the right side. So here you can see magnesium is it's 1 atom of magnesium, but we've got 2 of them because of this coefficient. We've got O2 here, oxygen, molecular oxygen with no subscript. So it's just these 2 atoms of oxygen on the left side. On the right side, we've got magnesium oxide, so that's 1 of each. But we've got a coefficient of 2 here, so we've got 2 of each. We've got 2 of these molecules that each have 1 magnesium and 1 oxygen. If we were to read this, we would say magnesium and oxygen yields magnesium oxide. When you see that arrow and you're reading across it, that arrow means yields. Basically, it says that our reactants on the left side turns into our products on the right side. And that's the end of it for right now. This quiz will be posted online, and remember, this quiz is going to be used as your participation credit for watching this video. So turn in that quiz. One thing about it, it's formatted like a quiz, but you get as many chances as you want on it. So feel free to take it as many times until you get 100% on it. If you complete it, how it should work, you should be able to see your score right away, and you should be able to see the questions you got wrong, but you won't be able to see the correct answer. So if you got something wrong, you might need to come back, watch this video, or go through the slides again to get the right answer. But you can retake the quiz as many times as you want until you get 100%. It's 9 questions long, so shouldn't be too bad. And it's just going to go over everything that was in this video. And that's what's for participation today. Thanks, guys.